Instead, we're going to have a talk from a great person and someone who describes himself as a man who likes cats. Give it up for Corey.
Hello. Oh, look at that. All right. If you came here for a differently titled talk, sorry, there's a little mix-up, but we're just going to be coding and live coding through this, so enjoy. I wanted to talk about some of the things that I've picked up when I help people learn type systems and move from sort of like the very basics into sort of one step further. I'm going to be using TypeScript, which I'm hoping that at least gives a common language that people can read and understand. It's very JavaScript-like, so I tend to use other languages as well, but this will be a kind of a common language for us. So I wanted to go over a tiny bit that when we first start, most people when they first start learning about types, they think about books and cars, and they are coming from like a Java or a C# background where you have nouns that are your type. And the reason that we come through with them is that we might have something like a book, and we have a code that like prints out a book, say, and it just prints out the title of a book. And the problem with just having something like this is that, of course, if we have a book, say, and we give it a title, we can nicely print it out, show book, my book, and it'll print out the title. Of course, the problem is if we try to show something that is not a book, say me, I'll tell you all my age, it's still, we will see it print, but we get an undefined on the second one. And this is a cause for a lot of hassle in production because you're running along and you get an undefined printed out and you don't know what was undefined. Is it bad data? Did I get it wrong from somewhere? Is it the wrong type? And so the first thing that we do to solve this, of course, is we create a type. And this is sort of the first level that we go to, is we make ourselves have something that's called book, has a title that's a string, and then we can annotate our function to say that it needs to be a book that comes in. So when we run our code, it does work fine, but if we run this one that is not a book, fingers crossed this is the first, we get what's called a type error. And we get an error that our compiler tells us that this is not valid code because the thing that I'm passing in is not the same structure as a book. TypeScript, in this case, is what's called structurally typed. So it looks at the structure. Is there a title? And this one does have the same structure as our interface. This one doesn't. And the big key difference here is that what we want our types to do is to prevent us from having problems in production. Like, this is a compile issue. This code can't make it into production until we fix the problem. And that's really nice. That's a first pass. It's great if you do Java, if you do C#. This is a lot of what you'll run into. But the next step, though, is we can be even more safe with our code. And we can use our code to make it so that the states that our system can get into are always valid. There's a saying that we kind of have called make impossible states impossible. And this says, if your system can get into a bad state in production, that's a problem because it's hard to debug. But if we can catch those bad states early on in the compile phase, then we can feel safe about safer about putting our code into production. So what I'm going to talk about and show are one simple, one slightly more complicated example of moving past sort of nouns as your type and into states of your system and using the type system to work with that. So we're going to build sort of on this book feature. And the first example is a fairly common situation is when you have a field that is sometimes editable. Let's make sure that I haven't broke anything. It'll still compile. Is that we might have a field that is sometimes editable and sometimes not editable. It's read-only. And a lot of times the way we'll model that is by having a simple little, we'll say like let our title, well, let's just let our title. And we'll have, like, you got the value as a string. You might have a Boolean that says whether or not you're editing. If you are editing, then you need to have a buffer, because if you have a buffer, then you can also cancel and get back to the original value. So when you're editing, you fill the buffer. Now, there's two fundamental problems here. One is that there are a handful of states that are bad. So for example, if editing is true, or if editing is false, but we have buffer is not empty. So one state that our system could get into is where we have buffer data, but the editing Boolean is false. And that's just a bad, that's rough, because the system, the coders, the developers are going to have to write a bunch of guards around that to make sure that I only use the buffer if editing's true. You can get situations where your editing is true, but the buffer is null. Ideally, you don't have any nulls around, but hey, we're in a language that has nulls and undefined. So what we want to do is take a little bit of a step to get rid of these invalid states. Let's figure out what the valid states are and encode those as the only options in the system. And there's another semantic issue with this, which is sort of a nitpick of mine, but is important, is that why is the variable called editing and not editing? So whenever you have a Boolean flag in your code, you're doing this really tight coupling between the true and false, which are effectively meaningless values, and the name of the variable. You're effectively a string. And so coming through here, you're putting a lot of cognitive load on the people who are working in the development, saying, hey, you have to remember that true is editing. And you could argue that maybe the natural state should be not editing and that should be true. And the problem with having this semantic coupling with a string is that I could change this at any time to not editing, and nothing in my system is going to tell me that. I may have some tests, hopefully you have some tests, but they'll fail. Probably some tests will fail that won't point you exactly to the fact that you changed the understanding of this. So this leads to sort of the first principle, one of the first principles of using types to model our states of our system. Is what we'll do is we'll take the two possible values of this Boolean and we create types for them. So we have a type for when we're editing, which has the original value and a buffer. And then we have a type for not editing, which has just the value. And at that point, we can actually have our title be, oops, let's put it somewhere else, put it here. Then let's have what's called a union type, which brings these two independent types together so that we can have a variable that can be either editing or not editing. And that one, we can have something that's called like editable, which is either not editing or editing. And so now we can type our title as editable. And what this does is this says that whenever I see this variable somewhere, I know that it is either this type, not editing and it has a value, or it's editing and I have my original buffer. And so it's nice because we can then build some functions that move it around. So we can take in something that is not editing and return something that is now in editing. and it's a simple matter. Nice thing about structural typing is that you don't have to play around too much. You can just create a record like that. And then you can have a function for like setting the buffer. You can take the buffer as a string, take your book. It's got to be in editing now. Oops. And it returns another editing because we're just setting the buffer. And in this case, we can take our record, set the buffer to be the new buffer, return the record. Now, just, this is mutation. Don't do this, create a new record. Mutation's not a great thing to have in there, but I'm going to do this for simplicity of reading the code's sake. The nice thing then is that if I set my title to be editable, and I create one, say, Moby Dick, there's a small little side thing in TypeScript that makes me cast this first original thing of it. There's ways to work around it, but it's kind of outside of the scope of this talk, so we'll cast it original. We'll create this title, tell this compiler that it's not editing, and then I can say, like, we could print it, and then we can say, well, let's make it start editing. You know what? This needs to be a record, I'm sorry. There. So then we can tell it to start editing. We can print it out again. We can set the buffer to something like a Clockwork Orange. Set our editor in there. Let's bring it up. And now if we run our code, fingers crossed, you can see that the first time we're in the type where we're not editing. We just have the value. We've switched over now to editing. We have this buffer. The interesting thing is that because we only can set the buffer if we are of type editing, if I say don't start editing, and I just try to set the buffer, then it won't compile. It actually tells me that there's a type problem. Your variable is not set to be editing, so you can't set the buffer. Now, you can do these checks, of course, in code and in the runtime, and in the function like ask, are you editing or not? But that, again, happens in production when your users are trying to work with this and they're getting errors. Almost always it's going to be undefined as not a function because it's JavaScript. So this is one really nice way that we can use the type system to sort of set up almost a state machine. And the way that the type inference works through, and not just the inference, but the type passing through your code, is that it will track the changes to your variable's type. So there are a lot of code paths that you don't need to write explicit tests for, because if you were right that you can't actually get the thing to compile, so that you can't write the test any case. But the compiler will actually walk through your code and go, aha, your variable has somehow been switched to not editing, and you're still trying to set the buffer. And that comes in pretty handy. You can then build some functions that will go like, take a record, convert editing over to not editing, which is pretty easy. You just have to return the buffer. You can write you can write canceling, which takes an editing and goes to a not editing. It just, instead of the buffer, it uses the original value. So you can build these nice systems in here. And you can actually come here and say, hey, I want to stop editing my title. And then if I try to set the buffer, so through my code, through some of the paths, I've switched it to editing, I've set the buffer a little bit, I've stopped, and then somewhere further down, you try to set the buffer again. Always the joys. You'll get argument of type not editing, is not assignable to parameter of type editing because when I tried to set the buffer, that record has to be editing. But it's actually, I've already stopped editing. So this provides you a really nice safety net around the code paths that you're writing. Because it can be so difficult in production to figure out why you're trying to set a buffer, why it's calling that, following through call stacks, things like that. Now, we can then use this in that original book that we had. So we can start to expand the book to have fields in it. It's not just individual variables, but we can actually have fields that do it. So we have to be a little bit here, but if we show the book now, let's comment some of this stuff out because it's just going to clutter things up. So now if we set our books field, the title field, to be editable and something of type editable, then we can use the value, or we can see that it's now just has the value in it. And if you come here and you try to set, we want to start editing it, the mybook.title, again, we have to unfortunately, as a shorthand, tell TypeScript the very first time that this is of type not editing. Now we can actually, showbook is the function, and provided everything's happy, you can see that we've now switched the type of it over. And you can then use everything that we saw inside of when we were working with just the set variable, that title field. So you can change this one to a Clockwork Orange, passing in your title. We no longer really have to tell it. We don't have to cast it anymore because TypeScript now knows, and so you can see that we've changed it. We can come in here. Last but not least, we can stop editing on mybook.title. Oops. And we can come through and do it. And this is very handy because if you think about it, a lot of times in our systems we'll have that user interface where it's shown you have an edit button, you have a cancel. So when they hit the edit button, you can switch it over to start editing, cancel, you can just say cancel, things like that. Comes in very nicely, and you save yourself from having those weird situations. And your compiler, you can actually get them into production, which I'm going to continue to repeat because that's really the big benefit of this. And then if you happen to be stop editing, you still get that benefit of not being able to change this. You'll get caught if you want to. If your system is somehow still trying to edit, it will do the code path checking. Oh, did I not stop editing? Oh, now I'm going to call that off the cuff that somehow I'm not sure exactly what's supposed to be why that didn't work. But I'm not going to waste time with that because I just kind of threw that in there. So in any case, we've seen it work. I don't want to debug on stage impromptu code. So that's the very first sort of step that we're going through that we look at. Very simple two things. I want to expand it into a slightly more complicated one. Before we do that, always good to take sort of a breathing break and look at my cat. This is little Miss Louise. So, and you can see her murder mittens out there too. So anyways, back to code. So switching one Boolean is nice, but of course we can do that in runtime, and it's fairly straightforward when we have it. It doesn't save us a tremendous type of stuff or a tremendous amount of work. However, there is a case where we have a more complex thing. In sort of modern environments, it's very common for your application to need to go call an API to get some data. And during that call, we have a bunch of states that we go through. So if I were to say, hey, let me have some books, and I need to load this list of books up off of an API, one of the things that we can do is look at what are the sort of states that we can be in. So if the list is empty, is it because we are waiting, or haven't made request, or failed? We can have, did we get an error? Track it. Did it load successfully? So we have all of these different states that we need to know about. And so one of the ways that often we'll do it is we'll make a bunch of Booleans. So we'll have our data, which is the books. Oops, a list of book. Let's get rid of that highlighting. And then we'll say, okay, has this been initialized? Meaning, have we actually done anything yet? Is it emptied for a reason? Is it loading? Did we make a request already? And if we've made the request, are we running, or we don't want to make another request? So do we have an error? If so, let's have an error message like this. And so what we want to get to is looking at these 3 Booleans. If you have 3 Booleans, you have effectively 8 states, 1 for each one. But if we look at it, we say, well, we've kind of got 4 states. We have that the list is empty because we haven't initialized or not. We have that we haven't made a request, or we are making a request. We have, did we get an error? And also, did we load successfully? So that if we have 8 possible states, but only 4 of them are really valid, that means we have 4 states that are invalid and should be made impossible if we can. And those are things like, oh, what happens if error is true and initialized is false? What is that state? What about we're loading? We've made the request and we're waiting for the request to come back. But errored is also true. That's a weird situation because we're waiting for the request response, but our error has been set to true. These are all states that shouldn't happen. I won't go through all of them. But what we can do is list out really what's the state flow? What is the flow of the system? What's our effectively the state machine that we're going through? And pretty much for every API request that comes back, we have a couple types. I haven't asked yet. I've loaded up the system, but I haven't even bothered to ask for the books yet. I've made the request, but I'm waiting for the request to come back. This is when we can show a little spinner on the screen. I've been successful. It's come back, I got the data. And failure, meaning we've got an error comes back, we want the error message. Now, if we build that, we would build that with just a nice type. I call it remote data. I didn't name it, somebody else did, but it's a good enough name. So we can take this, let's make it a little easier to read, and just list out the, there we go. List out the possible states that it can be in. We have not asked, we have loading, we have success, and we have failure. That allows us to take our books interface, which, let's change this into an interface, which means we get rid of that. And we no longer have to have these 3 Booleans. We get to replace them with just a state that is remote data. And that state variable will have only one of 4 values. Don't be fooled by these strings. This type says, if you are of type remote data, you have 4 values. Think of it similar to like an enum, but it's not. It has some different stuff to it. Now, the other thing that we want to have is getting rid of those situations where we say are in the not asked phase, but we have data. Or we're in the loading phase, but our error message is present. What we need to have, really, is specific types for success, remote data success. This has our, we'll just say books, like that. And we have an interface for remote data error, and that just has our error message. And this means that if we change this type, then we can get rid of these. And so at this point, our interface just has the state, which begs the question of whether we need this even at all, or if we can just have let books be remote data. If you know some type system stuff, or if you've worked in TypeScript before, or even Java or C#, you can actually make this type a generic type, so it's not just for book, but that's cluttery syntax for what I want to focus on here. So if we have this, we can then come in and go, we could build functions that have like, retrieve data, which takes our books as a remote data, and then it returns a remote data, and do whatever, API call we have, and then just return our books. Or actually what we'd be returning is loading. But this, again, we have to put checks in here to make sure that we only want to go to loading. We only want to make the API call if we are in the state of not asked. That's what the state machine looks like. It goes from not asked to loading to then either success or failure. And we can be more explicit and say that you can only call this function if you are in the state of not asked. And so if I set books equal to not asked, and I try to call my function, passing in books, it works. But if I am in if I'm in loading, say, a different state, then I get a type error. So if my variable has moved on from that first state, then my compiler won't work. And remember, this does nice code path analysis. So it will be able to, it does dig in and know that, hey, the way you've built your code, you've retrieved the data, and then for some reason you're trying to make the request again, which is generally something you don't want to have happen. You want to do that later. And you can encode, you can really just sit and encode all of the different types, or all the different situations. So you can encode what happened, the handler for when it's successful needs to be just loading, and it gets the data that came back and returns us a remote data success. Which is what this looks like. You can write the handler for retrieval error. Only can be done when you're doing a handling, and then you can have like the error message as a string. Okay. And then we can have message as error message. And at this point, we can come in here and say, like, okay, we'll just pretend that we have, it comes back with an empty array or something. But if we look at this, provided I typed all that correctly, which I didn't, which which now we are going to do it. We're going to look for books. Oh, there we go. New books. This I will debug. There we go. New books. And if you get it, you can see that it's not available. There's still, what do I have wrong in my code? I have it all written nicely, so let's, This is what I remember saying, like, oh yeah, this is when everybody starts yelling it out, and I am like, oh, I don't see it. What is it saying? Not assignable books? Oh, an S. There. Yay, debugging. So you can see that we can then have the actual state machine encoded in, and if I have retrieved successfully, then, and I try to like go retrieve the data again, my code paths have somehow gotten confused, and I'm trying to make this request twice even though it's come in, I get again a type error at compilation time. And so you can encode the business, or the business rules for your state machine into your types themselves, and then have the compiler check it, because this will keep you then from letting it get into production. And these are a couple, like two sort of concrete examples of ways of using this, what's the core principle of turn Booleans into specific types and move your data into the type that needs it. So we took those 3 Booleans, turned them into the types not asked loading, remote data success, and remote data error. And then we took the actual data so that it is only present in our system when we are actually want to have it. Did I fix it so it'll compile again? I did not, so let's run this real quick. So you can see that if we look at our state by each time, the only time we actually have this books value, this books array, is when we are in our success mode. And so I would implore you, whenever you have these flags, try to switch them over. Look into using your types less, or not less, but not just for encoding your domain objects, but think about the states that your system can go through and have those, and encode them using some of these tricks. There's, of course, lots more, but we only had 30 minutes. So that's it. Thank you. I guess there's questions. I don't know if there's questions, but there's 8 minutes worth if anybody wants to ask a question like why TypeScript? No? How many people use TypeScript? Okay, then I'll say that's why TypeScript. It actually has I really like the type system. Okay. If there's no questions, do we just end if there's no questions?
Let's have a look. Do we have any questions, guys?
No.
Yeah, we have them.
Oh.
If there hadn't been any, I was going to ask you about your cats.
Is this Slido?
This is Slido, who are a sponsor.
Wow, okay.
I'll read it. Sorry, Corey.
Okay.
Using types increases safety, but adds extra complexity. How do you decide when it is worth it or not?
So one of the things I like to think about is, what's the impact of failure in production? So if it's going to cost you money if your system goes down, then having the extra safety is worth it. Having just basic types for everything really is pretty much always useful. But when you get into things, especially in TypeScript, which has a great type system, and you get into things like optional types and type maps and stuff like that, it can get more complicated. And so you just have to balance the amount of time it's going to take new developers to sort of grok what is happening and be able to follow your code base with what's the impact if it crashes in production. So I'll admit my day-to-day front-end language is Elm, and I've run Elm in production for 6 years now, and the only runtime errors that I get are when I'm parsing JSON. That's it. Like the system, there's no null, there's no undefined, and you have to define. It does type inference, but you have to define all your types. So it is always a trade-off. Okay.
There are no questions about cats in here, people. Get your questions about the cats in. But meanwhile, Dominic says, would you design the next language without a Boolean type altogether? Smiley face.
I would, because a Boolean type, Booleans are good for one thing, which is the result of a logical operation. So you can actually just simulate it with a type that has values of true and false. So the thing about having a Boolean is that you also suddenly have if statements. And that's a whole nother talk about if statements.
Are you preparing for the question, Corey?
I am.
Okay, I'll fill while you're doing that. Anonymous asks a question which we'll get to in a minute, but underneath there's one that says, can we get more cat pictures?
If we switch over to mine, there's another.
Switch over. Can we switch over to Corey's? Thank you. Sorry, guys. I know it's out of the ordinary, but this. More.
Okay, one more, because, well. Oh, it's the same one. This is my favorite picture of her, so I think I have it just saved in a bunch of ways.
Oh.
So.
Okay. Sorry, can we go back to the questions? I'm making it really difficult for the team. What about more traditional type systems, such as Java or C#?
So Java and C# type systems are fine, but they're focused more on, they're much more focused on the nouns of having classes and interfaces that are my book, stuff like that. You can do a lot of this stuff in there, but they don't. It's been a long time since I did Java and C#, but I don't believe that they have what are called additive types and algebraic data types. And if you are missing algebraic data types, then you are missing a lot of the value that you can get from it. It just expands it into where you can have these things where you have a type that has 4 values. Some of the values have extra data associated with them, and you can simulate it in Java and C#. And I would encourage you to look at it and try it and see what it looks like when you do that, because you can with an interface.
We've got time for one more. Is this applicable for enum flag?
Oh, the TypeScript enum. No, this probably, but you get really expansive with a lot of this stuff, and so you start using a lot more of the capabilities of the type system. Enums are a very small subset of what you can do with that. I do have an LSP client in NVim, but I just don't have it running. How would you handle data from outside world? This is a really good example where it doesn't compile to a type declaration. Look up things called decoders and encoders, because when your data comes in, what you want to do is you want to have at the edge of your system, as close to the outside world as you can, you want to parse that data into types. Because if you're getting this data, then you should know what you're expecting, and you should be able to convert it into concrete types. And if you can do it right at that edge, you can also fail quickly. So you can look at it, and if it's a data format you don't understand, you can convert it into a failure type and have your system know that this happened to fail and run through a different code path as soon as it comes in. Then you don't crash because you're expecting a different type. This is a wonderful question. Okay.
I have to stop you there, Corey.
Okay.
If your question's up there and it wasn't answered, you can accost Corey down here
Yes,
at the
of
front
course.
left of the stage. If you want to see more cat pictures, you can try and do the
I
same
have
thing.
lots of cat pictures.
Do it.